Welcome to our journey into the fascinating world of anatomy and physiology. Today we'll delve into a crucial aspect of life, chemical bonds. In the intricate world of anatomy and physiology, all living organisms are composed of cells. These cells are in turn made up of molecules, and the building blocks of these molecules are atoms. At the heart of every atom are positively charged protons, neutrally charged neutrons, and negatively charged electrons orbiting around the nucleus. The fascinating thing is how atoms come together to form chemical bonds. There are three main types of chemical bonds: covalent, ionic, and hydrogen bonds. In a covalent bond, atoms share electrons, creating a strong bond between them. In fact, when you think of covalent, think of sharing. We even see this come up in other words in English like cooperate, co-parenting, and coordination. This type of bond is common in molecules such as oxygen and water. There are two types of covalent bonds, nonpolar and polar. Nonpolar is where electrons are shared equally and the molecule has a neutral charge. I like to think of nonpolar bonds as being like a couple that's in a really good relationship where both people share equally, like these two oxygen atoms sharing their electron equally. This forms the molecule of oxygen. A polar covalent bond is where electrons are shared unequally, resulting in a section of the molecule having a slight positive or negative charge. So for example, the bond between hydrogen and oxygen that makes water. Here we have a bond between a hydrogen atom and two oxygen atoms. But the oxygen doesn't really share the electrons equally, so this bond is unequal, with oxygen getting the electron most of the time and only occasionally sharing it with the hydrogen. I'm sure we've all been in a relationship like that before, where you give and give but only get a little in return. Because electrons are negatively charged, this causes the oxygen atoms to be slightly more negatively charged overall, and the hydrogen atom to be more positively charged. While water is formed through a polar covalent bond between hydrogen and two oxygen atoms, the way water works is a little bit more complicated than this, because it also involves hydrogen bonds, which we will discuss in a little bit. Ionic bonds form when atoms transfer electrons, resulting in charged ions. Oppositely charged ions attract each other, creating a strong bond. An example is the bond between sodium and chloride ions in table salt, or sodium chloride. You can think of ionic bonds as being how opposites attract. I like to think of them as being bullies. For example, we have our little sodium ion here playing with its electron, and along comes the chloride and steals the electron and keeps it for itself. Hydrogen bonds are comparatively weaker than covalent and ionic bonds. A hydrogen atom with an electropositive charge from one molecule is attracted to an electronegative atom of another molecule. So let's go back to that example of water I gave earlier. While the bond between the hydrogen and oxygen is polar covalent, this leaves the hydrogen with a slightly positive charge because an electron isn't being shared with it equally. Because hydrogen has this positive charge, it is going to form a very weak bond with the oxygen atom of another water molecule. Remember, the oxygen atom is going to have a slightly negative charge because it is getting the electron more than the hydrogen. So in this case, the hydrogen bond is between these positively and negatively charged atoms in each individual water molecule. Think of this hydrogen bond as being very weak. Almost like two pieces of Velcro sticking together, or like two people just sharing a brief hug. They don't last long and are easily broken. These chemical bonds are essential for life. They enable the formation of biologically important molecules. Water, a fundamental molecule for life, owes its unique properties to hydrogen bonding. These bonds give water its high heat capacity, cohesion, and ability to dissolve substances. Proteins are vital for various cellular functions. Their complex structures are shaped and stabilized by a network of covalent and hydrogen bonds. DNA, the genetic blueprint of life, forms a double helix held together by hydrogen bonds between complementary base pairs. In terms of overall strength, the prize definitely has to go to nonpolar covalent bonds as being the strongest type of bond there is. After that, we have second place to polar covalent bonds. The bronze medal would go to ionic bonds, and hydrogen bonds would be the weakest. So the next time you write that love letter to a significant other, don't talk about how your love is strong or will last forever. Tell them how your love is covalent. And there you have it. Chemical bonds are the building blocks of life, holding together molecules essential for the functioning of living organisms. Without them, life as we know it would not be possible. I hope you enjoyed this exploration into the world of chemical bonds. Join us next time as we delve deeper into the wonders of anatomy and physiology. Stay curious. If you enjoyed this video, please give it a thumbs up and share it with others. To keep informed about new videos being created, don't forget to subscribe to our channel and hit the notification bell. If you have any questions or topics you'd like for us to cover, feel free to reach out and let us know. Thanks for joining today, and see you in the next video.